Alright, this is section 1.3. We're going to define trigonometric functions in this section. So we're going to kind of think about SOHCAHTOA. We all ultimately have seen that at some point in our math career, but if we don't remember, SOHCAHTOA, which is sine is the opposite over hypotenuse idea right here. Cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We're going to use those ideas and then combine it to a coordinate plane, and any coordinate point that is plotted in the unit circle, we're going to kind of imagine that there's a circle around here. That's actually a decent circle too. Okay, we're going to imagine that our x-coordinate, okay, and then the y-coordinate, and then our radius is the hypotenuse, and that makes a right triangle. So for basically the rest of this entire class, I'm going to refer to sine in terms of y's, x's, and r's of the world. I might say it that way. Sine is going to be the opposite, or the y value, over the r, or the radius, because it's opposite over the hypotenuse, which is the radius. Okay, cosine is going to be x over r. It's the adjacent over the radius, or the hypotenuse. And then tangent is going to be y over x. And then in turn, we're going to end up saying that's sine over cosine in due time. But tangent is the opposite over the adjacent. So y over the x value. And then hopefully we know that these relate to the other three trig functions via being reciprocals of each other. So cosecant relates with sine, secant relates with cosine, cotangent relates with tangent, and notice that these fractions just flip-flop, or they're the reciprocals of them. Okay? So we're going to kind of, that's the circular plotting the point type of definition for sine, cosine, and tangent. Now we're going to use that idea given that if I plot a point, and this is a big typo, that's supposed to be theta if. So I'm going to find the 6 trig functions, all of them, in standard position of the point -2, 3. So here's what needs to happen. You need to draw this out. Plot the point -2, 3. So I need to go 2 to the left, 3 up. Puts me in quadrant 2. So I have a terminal line, or terminal side of my angles going through there. Well, I'm going to make a triangle, a right triangle to be exact, using that point. Your theta, which I call a reference angle, is always going to be between my terminal side and the x-axis. You always go towards the x-axis. If the point was down here, you would go up. If the point was over here, you would go up. If the point was in the first quadrant like this, you would come down. Always go towards the x-axis. So in this case, I know the x-coordinate is -2. The y-coordinate is 3. I have two sides of my right triangle. I need to find the missing side. Well, that's just the hypotenuse. So I can use Pythagorean theorem. -2 squared plus 3 squared is your radius squared. So 4 plus 9, 13. So it's the square root of 13. Now, it's always the ability to do plus or minus the square root of 13. I maybe should say that when I solve. Oh, this should not be squared. That should be the first power. But it's always going to be the positive one. If it's the radius will always be positive. Now the x value can be negative and the y value could be negative, but the radius or the hypotenuse will always be positive. So now we have every side of our triangle. We need to find the 6 trig functions using SOHCAHTOA. So my sine theta, which is your y over your r, or your opposite, which is 3, over the hypotenuse, which is the square root of 13. And by now we hopefully know that we cannot have a radical on the bottom. So if I go square root of 13 over square root of 13, I get 3 root 13 over 13. There's one of them. Okay? The easiest thing to do when I do these 6 trig functions is find the 3 common ones. Cosine, the x over the r, which is going to be adjacent, or x, which is -2, over square root of 13. Which will end up doing the same thing. Multiply square root of, well, I can't write 13 over the square root of 13. So -2 root 13 over 13. That's cosine. And then tangent theta, alright, is just going to be your opposite over your adjacent, or your y over the x. So -3/2. And it's that simple. Now to find the other 3, it's really, really nice because you just need to do the reciprocal. Now it's not always the smartest idea to use the ending answer after you simplify. This original guy is going to be a lot easier to flip because you don't have to do any extra work. So what's related to sine? Cosecant theta. And I have 3 over root 13 as my initial sine idea. So if I flip them, it's root 13 over 3, and it's simplified. So there's cosecant. Secant theta, I know relates to cosine, so I'm going to do the same idea. I'm going to go in here and take my original setup. And so I know it's negative root 13 over 2. And then cotangent theta, I just flip tangent, so it's negative 2/3. And those become your 6 trig functions given this original coordinate point being on the terminal side. So you could plot any coordinate point, find the missing side, and then do your 6 trig functions from that triangle. Okay? The last part of this is going to be focusing on your special triangles. So we now know that the relationships is 1, 2, square root of 3, and this one's going to be 1, 1, square root of 2. We're going to kind of use those ideas to find every possibility of any special triangle that we have for the 6 trig functions. So this first one, the 30s and the 60s, I'm just going to draw a triangle in here. And then this is a 30, 60, 90. This is 1, root 3, and 2. What I want to do is think about sine, cosine, tangent, opposite over adjacent, and so on and so forth. So sine of 30, let's just start there. Here's my 30-degree angle. Opposite is 1. Hypotenuse is 2. Simply done. And we're going to use these enough that we need to start essentially memorizing them. As scary as that is, that seems like a lot. But sine is 1 over 2. Cosine of 30. Adjacent is root 3 over 2. Okay, tangent of 30. Opposite over adjacent. So this ends up being 1 over root 3. I need to do the root 3 over the root 3. So it's square root of 3 over 3 for the tangent. And then how do I get the other 3? We quickly should be able to flip these. Okay? So I know that cosecant is going to be the reciprocal of 1/2, which is just 2. Secant of 30 is the reciprocal of cosine of 30, so it's going to be 2 over root 3. But then you need to rationalize. Oh, that's a 3, not a 13. So it's 2 root 3 over 3. And then cotangent, what's flip-flopped here? I'm going to go back to this original one again, kind of like the other problem. If you flip 1 over root 3, it's just going to be square root of 3. Alright, so that's how we kind of can go through it. Now the middle column needs to focus on the 60 degree. So I'm going to imagine myself up on this part of the triangle instead. So if I go up there and I say what's the sine, it's going to be opposite, which is square root of 3 over the hypotenuse, which is 2. Cosine is going to be adjacent over hypotenuse, or 1/2. And if you kind of notice that these things relate, they just kind of switch. So that's kind of a note to talk about. Tangent 60. So tangent of 60 is opposite over adjacent, so that's just the square root of 3. And then I can flip these things. Alright, so cosecant relates to the sine of 60, so it's like 2 over root 3, but I can't really have that, so I have to do this radical business. So it's 2 root 3 over 3. Secant is just going to flip-flop your 1/2, which is 2. And then we have to flip square root of 3. So then I got to do the radical business again. So square root of 3 over 3. So that's how you find each one of those. And then the 45, 45, 90, this actually isn't too bad at all, because that's definitely not a 45, 45, 90 triangle, but please go with it. Sine is going to be your opposite over your hypotenuse. So 1 over the square root of 2. Do the rationalizing the denominator, so it's root 2 over 2. And if you think about it, the cosine is going to be the exact same, because that's also going to be 1 over square root of 2. So I'm just going to write square root of 2 over 2 via the same work right above. Tangent's really easy because it's opposite over adjacent. 1 over 1 is 1. And then to get the other 3, pretty easy, you just flip-flop. So once again, I'm going to go back to that original starting spot. 1 over root 2 can flip to be just the square root of 2. Secant also can be the square root of 2. And then cotangent, you just flip-flop 1 over 1 as 1. Okay? So that's the quick and easy version of your special triangles. Now, other things that we might see are using the unit circle with quadrantal angles, which means you end up right on the quadrant lines, which you're either going to be at 0 degrees, 90 degrees, 180 degrees, or 270 degrees. So I'm just going to focus on 0 and 90. The 180 and the 270 focus the exact same way. Okay, now we're plotting points. We got to think about what's the x value, the y value in each one of these, and then tie that to our trig function. So I talked about that sine is y over the r. So at 0 degrees, what's my y value? So straight to the right, my y value is 0 over my radius. Now this is a unit circle. The distance from the center to any point on my unit circle will always be 1. Okay, so the r will always be 1. Well, 0 over 1 is 0. Cosine of 0 is the x over the r. X over r is going to be 1 over 1. Because you're 1 unit to the right for the x value, and the radius is also 1. Tangent is y over the x. So your y value is 0. The x value is 1 to the right. 0 over 1 is 0. And now the fun begins, the trickiness part of this. You flip them. Okay? So if I want cosecant, I need to flip-flop 0 over 1. Well, that's 1 over 0. That's a problem. I cannot divide by 0. So this is undefined. You cannot define cosecant at 0 degrees. Secant, on the other hand, if you flip 1 over 1, it's just 1. And then cotangent, like cosecant, will also be undefined because it's 1 over 0. So undefined. So that's 0 degrees. What happens if I change it up on you and I put you at 90 degrees? So that's straight up. So your x value, you're not moving left or right any, but we're going 1 unit up for my y value. So it's the same process. Sine of 90, what's the y over the r? The y value is 1, r value is 1. So my sine of 90 is obviously 1. Cosine, what is the x over the r? Well, x, I'm not left or right any, so it's 0. Radius is still 1. Notice once again that the sine and cosines kind of flip-flop to a point with these particular problems. And then tangent is the y over the x. So the y value is 1. The x value is 0. I cannot have that. That's undefined, because I cannot divide by 0. So then if I change it up and I figure out cosecant 90, if I flip 1 over 1, cosecant is 1. Okay? Secant, if I flip 0 over 1, that's the whole 1 over 0 problem. So this time secant's undefined. And then cotangent, if I flip-flop 0 over 1, that becomes, I apologize, if I flip-flop 1 over 0, because that's what tangent is, it becomes 0 over 1. Which that means that cotangent is 0 at that point. Okay? This says defined. That should be undefined. I hope you guys got a laugh out of that. Alright, and then the last problem. I'm going to give you a trig function that has its relationship. I'm going to tell you that it lies in a particular quadrant, and you have to find the other, let's see, it says the other 6. Technically, it should say the other 5. So I say it lies in quadrant 3. So here's what I need you to do. Make a coordinate axis. Quadrant 1, 2, 3. I'm going to make a triangle. Here's my terminal side, and then you always make the right angle on the x-axis. Here is my theta, always in between the terminal side and the x-axis, so always in here. And I know that sine is your y over r, or opposite over hypotenuse. So this becomes this is your x side, here's your y side, here's your r side. So I know that my y is 5, my r is 13. One of them needs to be negative. Well, your hypotenuse, the radius, will always be positive, which means that my y value must be negative. So I know that it's negative 5, and then the radius is 13. I need to find my x in order to do the rest of it. So I'm going to use Pythagorean theorem. X squared plus the negative 5 squared equals 13 squared. X squared plus 25 equals 169. Subtract it. X squared equals 144, which leads me that x is plus or minus square root of 144 is 12. Is it the positive or negative one? You have to think about it. Where am I located? The x value, and I'm to the left. So it needs to be the negative 12. And from there, once you get your triangle, you actually should be able to do this relatively quickly. Sine theta, I'm already given. I don't have to think about it. Okay, so that one's done. Cosine theta, that is the x negative 12 over the hypotenuse or radius, which is 13. Tangent theta is your y over the x. So what is negative 5 over a negative 12? Two negatives make a positive, and you need to simplify it that way. And once you have the three regular normal ones, the rest of them fall into place quickly. Cosecant becomes negative 13 over 5. Secant becomes negative 13 over 12. And then your cotangent is 12 over 5. And that's how you find your 6 trig functions, given that I give you one of the trig functions with its relationships and tell you what quadrant it's going to be in. And we'll do a bunch of these in class as we continue on with our chapter. So I hope that you all have a wonderful day.